Okay, hello everybody. So in this particular lesson, we're going to discuss some very basic concepts involving geometry. Geometry is a very visual type of segment of mathematics, and there are lots of particular theorems and postulates and a lot of particular things that you need to know, but this particular lesson is going to touch upon the very basics that will sort of come up very frequently in more advanced topics in geometry. So if you understand these very basic rules of geometry, then you will be able to have a pretty good understanding of how things work in the geometric world. And it also depends on what particular geometric figure you are talking about. Okay? Geometric figures are like polygons, and polygons are multi-sided figures. Like a square has 4 sides, a rectangle has 4 sides, triangle has 3 sides, etc. So we're going to start off with a few definitions. One of them is a point. A point is literally one space, one location in space that has no length, no width, or no thickness. Okay, and a point is usually, is always designated, in a plane as a dot, and we label it a letter. Now, in this particular case, we're going to assign it letter A. So we just label that as point A. And a line is basically connecting 2 points. So the minimum amount of points needed to make a line is 2. Okay, so 2 would be very important, 2 points. Okay, and a line is a line connecting 2 points. So point A, point B is the closest or the fastest path to get to those 2 points. So if you're walking in a straight line from an initial point and you are traveling to another point, and if you take a straight path, no deviation left or right, okay, you will have traveled the shortest distance from those 2 points, in between those 2 points. Okay, so if you're driving and you go down a street, right, you go down a street and you want to go to the other end, assuming that that's a straight road, that is the shortest distance. But if it curves, okay, and it winds, then you're technically traveling a longer distance, okay, to get to that second point. And the symbol for a line is a line with 2 arrows indicating that the lines go, they don't end, so they go to infinity, either left or right, or one direction, and the opposite direction is the other direction. So let's say you're traveling eastbound, right, and you're pointing eastward, right, and then behind you is the other direction, west. So that's considered a line. So you would be traveling forever and ever in the easterly direction, and the line behind you would be traveling forever and ever in the western type direction, or westerly direction. That's the adverb that I'm looking for. So easterly and westerly. Okay, so that's denoted with 2 arrows, and there are 2 points on a line. So we usually designate 2 points on a line, A and B, or whatever letter you choose. And the symbol for that is A and B are close together with the line above it. Notice the 2 arrows. The 2 arrows have to be there, indicating that they go in opposite directions at infinitum, which means they don't end. All right. The next thing I want to talk about is a plane. So a plane is basically a flat surface, any flat surface. It doesn't have any thickness or boundaries. So a plane could go on forever and ever, and that's indicated with the arrows. We have a plane, sort of like a rectangular shape, all right, and it's going in all directions to infinity. It means it doesn't end. And we can label that plane as a particular letter of your choice, okay, if it's given in a diagram. In this case, it's plane P. Okay, so this is what it would look like. Okay, it doesn't really end. It just keeps going forever and ever in all directions. Okay, so a point, you go back to a point is one dimension, okay, because it neither has length, width, or height. But a plane could have both length and width. Well, just think of a rectangle. Look at the rectangle itself. That's two dimensions because we have length and one side is the width. A box would have three dimensions, right? Length, width, and height. And then the fourth dimension is actually time. Okay, but that's not really going to be discussed in this particular lesson, but just a little piece of information, interesting piece of information. Okay, now a ray is not a full line, it's actually a half a line going in one particular direction. So we have 2 points, okay, on that half line. Half line means that it's going to start at one point and it's going to go forever and ever in one direction. So if you drive and you start driving on a highway, you're going in one direction, right, at once. Okay, so if you're traveling northbound, then that's the direction you're going to. If you're traveling southbound, then you're traveling in one direction, not both. Okay, so this is labeled as ray A and B, and you notice the direction of the arrow is to the right. Okay, it doesn't have 2 arrows because it's only going in one direction, and vice versa here. We can label this as AB. You're starting off with the initial point, and then the second point would be the point that's going in that same direction in front of it. Okay, so think of A as the initial point, and then B is another point on that line going in that direction. And that's, you can label that as ray A and B. Notice that you start with the initial point and then the second point last. So notice the arrow's going to the left this time. And then a line segment is a portion of a line. It's neither going in one direction nor the other, all right? And it has 2 endpoints, meaning that this segment starts at A and ends at B, and that's it. And we can label that as segment AB. Notice it has the line with no arrows at all. That's indicated that it's a segment. All right. And another concept is an angle, right? What is an angle? Well, it's the union, okay, of 2 rays. Union meaning that they're connected at a point called the vertex. So the point, right, this vertex is where this ray, this is going to be a ray, and then the other ray is going to be over here. Okay, so the one that's going straight up and down or vertically is the first ray, and then you notice that it starts at point B and it goes upward, right? And then the second ray is the one that's horizontal. It starts at point B and it goes to the right. You notice that rays, the 2 rays meet or start at point B, and then they go outward. One's going straight vertically, the other one's going horizontally to the right. Okay, so that's what an angle is. It's when 2 rays start at an initial point and then they spread outward in different directions. The initial side is where the angle begins. So if you look from point A to point C, and then if you look at the arrow in between these 2 blue lines, you notice that it's starting at on the horizontal line, and it's going towards the second ray, okay? And we call that angle 1 because it's in between 2 rays. Okay, so the angle that starts at a point is the initial side of that angle, the initial side, and then the terminal side is where the angle ends. So the blue horizontal line from point B to point C is your initial side, and then the line or the ray from point B to point A is the terminal side of that angle. So think of initial as the beginning, terminal as the end, right? It's kind of like an airport terminal, right? You start entering the terminal and then eventually it ends when you go inside the airplane. Okay, that's like the most, one particular real life example. Okay, so we can name angles many different ways. We'll use this particular example, and you notice that the the letters A, B, and C are going to be used to identify this angle, but there are many ways. One of the easiest ways is that if this angle is numbered, like angle 1, okay, you notice the symbol of an angle is these two rays coming together at a point, and then this little circular type of mark here indicates an angle. Okay, so we can label that as angle 1, or you can use the letter that designates the vertex. In this case, it's called, point B. Point B represents the vertex of this angle, so we can call that angle B. Okay, it's another alternative. Another way you can say it is angle ABC. So if you start with the letter A, then the second letter would be B, and then the final would be C. It's kind of like a direction. You're starting at A, traveling to B, and then traveling to C. We can label that as angle ABC because that's where we started, A. Or you can do it vice versa. You can start at C and then travel to point B and then travel to point A. That's also known as angle CBA. So there are many different ways you can designate what the angle is as far as like symbolizing it, And that's going to be kind of important in geometry because we want to use symbols and notations. We don't want to keep writing angle, the words angle 1 or angle B or, you know what I mean? So we want to try to use symbolic representations of this situation because it's a little bit easier. Okay. Now, a little information about a circle. Okay, when you see a circle, you are traveling in a curved motion, right? It's a kind of curvature, and it's when you're traveling a circle. Let's say you start at a point, let's say right here, and then you're just traveling. Traveling around that circle. Sorry about that. Okay, let me try this one more time. So you're traveling in a circle. Okay, that's called counterclockwise because you're going in the opposite direction of a clock. The opposite direction that the hands of a clock would move. So that's called counterclockwise. And then if you keep going, right, you're eventually going to end up where you initially started. All right, that's considered one full revolution or one rotation, and that's comprised of 360 degrees. Kind of like a compass, right? You start at one point. Let's say you start, where it says south on the compass. That would be 180 degrees. Okay, and you go around the circle counterclockwise. Okay, so you would go around the circle in a counterclockwise motion, and then you'll end up in the same spot where you initially started. So you make one complete revolution or one complete, you travel one complete revolution around that circle. Okay. All right, so that would consist of 360 degrees. Now, if you have 1 degree, that's 1 over 360. So 1/360th of a degree. So if you have 40 degrees, then it's 40 degrees out of 360. 20 degrees out of 360. In this case, it's 1 degree out of 360. It's kind of like taking 360 and dividing it into 360 equal parts, right? You just have one of those parts. Okay? So let's look at a real world situation. Let's look at a clock. All right? We use clocks all the time. Now, if you have a digital watch, then this really is not going to apply. But let's say you look at a regular analog clock where you have the hour hand and the minute hand, and then there's also a second hand. But in this case, we're going to use the hour hand. All right, that would be over here. That's the hour hand, and here is the minute. Okay, the minute hand. So let's say the clock, the time starts at 12 noon, and then, as you know, the direction of the hands of a clock are going to move in a clockwise direction. That's why they call it clockwise, because you're traveling in the direction that the hands of a clock would move. Counter means against, so you're going in the opposite side, the opposite direction of where the hour and minute hand would travel. So kind of the clockwise is this way. Okay? And So let's say we start at 12 noon and then the hour hand moves to 2 o'clock. And let's say you want to figure out how many degrees did that hour hand move from 12 to 2. Well, the circle in this case is divided into 12 parts, right? 12 hours. And each hour represents a part of that circle. So if you're starting at 12 and you're going to 2, then that's basically 2 out of 12, right? 2 hours out of the 12 hours. And if you reduce that, it's the same thing as saying 1/6. And then in order to figure out how many degrees is that, well, you take 1/6 of that circle, you times it by 360 degrees, and you're going to get 360 over 6, which divides equally into 60. So it traveled 60 degrees. 60 degrees would be right here. Okay? All right. So, yeah, so it'll be 60 degrees, okay? And if you times that by 6, you will actually get 360 degrees. So this is 1/6 of a circle, right? You're taking a circle and we're dividing it into 6 equal parts, right? Each part is 60 degrees. Times that by 6, you get your 360 back. All right, so that's the basic concept of a circle and degrees, okay? There's also another measurement. Degrees can be radians, but we're going to not talk about that right now, okay? There are 4 types of angles that we should know before proceeding, right? So we're going to classify angles into 4 categories. First categories are acute angles, and acute angles is not a good-looking angle. It actually means less than 90, okay? And an example of that would be 2 rays connected at a point. This would be the point right here. This would be the vertex. Okay? And the rays point outward. And this little curvature signature here is the angle. All right? In between those 2 rays. So any angle that's less than 90, like 89 degrees, that's an acute angle. 40 degrees is an acute angle. 2 degrees is an acute angle. All right? 75 is an acute angle. Those are all acute angles. They're all angles less than 90. And then you have what we call a right angle, which is exactly 90 degrees. And that's indicated or denoted by a little box in between the 2 rays, indicating 90 degrees. Okay? That's what this little box means. If you don't see it there, then it's technically not a 90-degree angle. Okay? It could be 91 or 89 or something like that. So it must have that box in between those 2 rays, that little square box. And then we have an obtuse angle. An obtuse angle is greater than 90, but less than 180. All right? So anything greater than 90, like for example, 91 degrees is an obtuse angle, excuse me. 100 degrees is an obtuse angle. All right, 170 degrees is an obtuse angle. All right? But the minute it reaches 180, that's called a straight angle, because it's one line going in opposite directions. That's actually a half a circle. Okay, so look at it like this, okay, as a little bit of information. So let's say you start here, right, and then you make a half a revolution and end up on the opposite side. That, let's say this is 0 degrees, and if you make 1 complete revolution and you go from here, well, the point from here to here is 180 degrees. Or you can go back, right? You can go back in this direction, it's still 180 degrees. It's a half a circle. If you make another half a revolution, then you go another 180 degrees, and that would be 360 degrees. That's a full revolution. So a half a revolution of a circle is 180. And that's why straight lines are 180 degrees. Because you're literally taking the circle and you're going right through the diameter, okay? Right through the radius, or the center of the circle. Let's say the center of the circle is right here. And the diameter would be going right through that. There'd be a line going from one side of the circle right through the dead center of that circle and then to the outer edge of the other side. Okay? So here's the initial location and this is the final, if you're going in that direction. Okay? All right. So now, a couple more definitions or more terminology. Complementary angles and supplementary angles. This is really not hard. Just think of a complementary angle. when you have two angles that add up to 90 degrees. Okay, so an example is 40 degrees plus 50 degrees will give you 90. All right, that's easy, right? Or 10 degrees plus 80 degrees is 90. However, what if they ask you this question? What is the complement of 40 degrees? That means, what are the angle that we have? What is that other angle that when we add to 40, we get 90 degrees? So a quick way to do that, right? You take 90 degrees, which is the maximum it has to be in order to be a complementary angle. Take the difference of that angle that's given, which is 40, subtract it, and you get 50 degrees left over. Or you can just do it logically, right? If you have 40 degrees and you just keep adding increments of 10, right? 40, then you have 10 more, which is 50, 10 more is 60, 10 more is 70, 10 more is 80, 10 more is 90. So we had 5 increments of 10, that gives you 50. So you can kind of do it in your head if you want, all right? Or you can just take whatever angle is given, right, which is 40, and then subtract it from 90, and you'll get the difference of, in this case, 50. The next type of angle is a supplementary angle, and those are two angles that sum up to 180 degrees. So if you want to find the supplement of 110, well, if you take 180 and you subtract 110, you get 70 left over. So 70 degrees is what you have to add to 110 in order to get 180. So pretty simple concept, pretty easy to calculate. Okay, so let's do an example. Okay, and then we have these. Again, this is ray, this is a ray. And we're going to have some points, okay? And then we have a vertex here. We're going to call this first point C. This point will be B, and then this will be C. So let me go ahead and make sure I clear them. All right, and then we have this ray going out like that, and there's a point here, and we'll call that D. And we're going to designate this angle. This is the initial side, and then I'm going to the terminal side. That's where my angle ends. And let's say that's 62 degrees. And the question I want you to do is I want you to find the measure of angle DBC. We represent M as the measure. What is this angle? What's the measurement of this angle? So we put an M, then we put the angle symbol, okay? And then the letters designated that angle. You need 3 letters, okay? Not 2, you need 3. 2 would either be a line or a segment, okay? So we want the angle. And the solution to that okay, is that we want to find the measure of angle DBC. That's going to equal, okay, remember the angle DBC, okay, DBC. Notice the order. D, B, C, because that's what's given. D is first, B is second, C is last. So we need to go in that order. And that's how they're naming the angle. You can also name it as CBD, but in this case we're labeling it in this particular way, DBC. And we want to find that angle. Well, if this angle is 62, then we want to know what this angle is. All right? What is that second angle? Well, if you look at this, if you look at the ray starting at point B, traveling to C, okay, and then you look at the ray from point B and traveling to C, that is actually a 90-degree angle, okay? So if you want to know what the missing angle is in orange, then you would just do this. You would take 90 degrees, and then you would subtract 62 degrees, and then you are going to get 28 degrees. So the measure of angle DBC equals 28 degrees. Okay? So pretty simple problem to do. So we're basically finding the complement. Okay? All right. So that's an example. Now let's talk about a supplement angle. So let's do an example of one of those. So let's say we have a straight line. And we have 2 points on that line. We'll label that C, we'll label that B. And we have a point here. And we have another ray going out like this. There's also a point on that line, and we're going to call that D. And we're going to call this point here B. So, a couple things we need to know. The angle A B D, okay, okay, I accidentally had this on mute or pause, so let's go back to what I did. So we have a diagram here, and the measure of ABD is 66 degrees more than angle DBC. Okay, so look how I labeled them, right? ABD is 66 degrees more than angle DBC. So I labeled angle DBC as X because I have no idea what it is, but if you notice the other angle is 66 degrees more than, so we take the unknown angle, add 66 degrees, and that's how I would label that angle. And it's also telling me that these two angles are supplementary, which means that they add up to 180 degrees. Okay? So if you take those two angles, measure of angle DBC plus the measure of angle ABD, they absolutely, positively must add up to 180 in order for those two angles to be supplementary. That's really important. Okay? So since I labeled angle DBC as X, because we don't know what it is, and if I label angle ABD, we know that's 66 degrees more than X. So it's just X plus 66. It's not 66 plus X because it's more than, okay? But in this case, it's not going to change, but it's X plus 66, and that, as we said earlier, must equal to 180 degrees. So now we just collect like terms and solve this algebraically, right? X plus X is 2X plus 66 equals 180. We subtract 66 on both sides, so we get 2X equals 114, and then I divide both sides by 2, and I get X equals, 57 degrees. All right? And that would be the answer for that problem. Okay? Additionally, okay, so this side is 57 degrees, but what is the obtuse angle, right? The obtuse angle is greater than 90, so what we want to do is we take X plus 66 degrees, and we know that X is 57, so if I add that to 66, then I'm going to get 123 degrees. So that's the measure. So the measure of angle ABD is equal to 123 degrees. I'm having a hard time writing because my pen keeps slipping. So I apologize for that. 1, 2, 3. Okay? So you can find both angles. Once you know one, then you can fill in the puzzle, right? So if you go back, right, these two angles are complementary, which means they add up to 90. So if you're given one angle, in this case 62, well, if you subtract that from 90, because 90 degrees is the total amount of degrees it needs to be in order for it to be complementary, just subtract 62 from that, because that's given, and you get 28 degrees left over. So angle DBC is going to be 28 degrees. And now if you test it, okay, if you take 28 degrees, and if you add 62 degrees, we get 90 degrees, so it checks off. It's correct. Okay? So know the difference between supplementary and complementary. It's really important. Okay? All right. So another thing that we have is vertical angles. And this is kind of easy. When you think of vertical angles, okay, just think of this. We have two lines that literally intercept each other at one point here. Okay, so we call this angle 2, and we'll call this angle 1. We'll call this angle, we'll call that 68 degrees, and then this would be angle 3. So we know one of the angles is 68 degrees. Okay, we need to find the other angles. We need to find angle 2, 1, 2, and 3. So here's the thing to keep in mind. Vertical angles are always going to be opposite of each other and equal. So if you look at angle 68, right, the 68 degrees, you notice the opposite angle is 1. So, it's kind of like if angle 68 degrees, all right, if this angle is 68 degrees, then the opposite angle is going to be 1. So if angle 68 degrees, then angle 1 is going to be 68 degrees as well. Angle 2 and angle 3 are also equal to each other. So let's find angle 1 was easy because you look at the opposite side, literally on the opposite side, and whatever the first angle is, in this case 68 degrees, then 1 has to be 68. But we don't know what angle 2 and 3 are. So remember that we have to remember one thing, okay? We know that vertical angles are equal, but opposite angles are going to be supplementary, which means they have to equal to 180. Okay, so let me do this down here. Angle 1 plus angle 2 will equal 180 degrees. So therefore, those two angles must be supplementary. Okay. How do we do that? Okay. Well, first of all, if you're starting at one point and you're going completely the opposite, that forms a 180 degree angle. So that's where that comes from. So we take 180 degrees, and that must equal the sum of angle 1 and angle 2. Okay. So angle 1 and angle 2 are adjacent to one another. So whatever angle 1 is, right, the remaining portion is angle 2, and those have to add up to 180. Okay, so here's how you do it. And then opposite angles, like I said earlier, is angle 2 and angle 3, and then 1 and 68. Those are vertical angles. All right, but the ones adjacent to each other, like 1 and 2, those are supplementary. So if we know that, okay, we know that angle 1 we said was 68 degrees because it's opposite of 68, right? So it has to be the same. And now we can solve this algebraically for angle 2. Think of angle 2 as x, right? A missing variable we want to solve for it. So we need to get angle 2 by itself. So if we subtract 68 on both sides, 180 minus 62 is 112 degrees. So angle 2 is 112. Now remember, angle 2 is completely opposite of angle 3, which means they're vertical angles. Okay? And if you know what angle 2 is, then angle 3 is going to be equal. Okay? It's equal to 112. So if you add angle 3, which is 112, and if you add angle 2, which is 112, if you add angle 1, which is 68 degrees, and if you add the other 68 degrees, which is the opposite angle of 1, they sum up to 360 degrees. They make a complete revolution, one circle. Okay? So that's how you do that problem. Okay, so let me sum up. Angle 2 and 3 are vertical angles because they're opposite of each other, and they're going to be equal. It's kind of like going in a straight line, okay? But, you know, that's how you know they're vertical, right? If you start at angle 2, you go in the complete opposite direction, you will find the other vertical angle, if that makes any sense. So I'm trying to think of visually, you know, how you do this. And if you start at angle 1 and you go completely the opposite angle is 68. So those are vertical angles. All right? All right. And any two angles adjacent to one another they're supplementary, which means they add up to 180. All right. So, all right, one other important topic. We're almost done here. So let's say you had two lines that are parallel. And you have one line intersecting both of these. It's kind of like the transversal. Transverse means to cross over something. So we're going to cross over these two parallel lines. And this is called a transversal. Okay, for terminology purposes. All right. And then these two lines are parallel. All right. So let's number these angles. We're going to start here. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we identified what parallel lines are. They're both going in the same direction. That means they never intersect each other. Intersecting lines will cross over each other and form angles. Remember, these parallel lines are both 180 degrees. All right? But when you have a transversal and you're crossing any line, it's going to form 4 angles. So the first 4 angles here, 5, 6, 7, 8. So look at the transversal crossing that parallel line. If it crosses again, it's going to form 4 more angles. And then there's some relationship between these angles. And I guess we'll start with this. You notice that angle 2 and 3 are vertical angles because they're opposite. So they're going to be equal to each other. Angles 1 and 4 are also vertical angles. Angles 7 and 6, or 6 and 7, are vertical. And then 5 and 8 are vertical. Okay? So you got 4 sets of vertical angles. Now look at angle 1 and 3. Those would form 180 degrees because they're right next to each other. Okay? So, angles 1 and 3 are supplementary, which means they form 180 degree angle. Angles 2 and 4 are also supplementary because they will both add up to 180 degrees. Angles 5 and 6 are again supplementary. They'll add up to 180. Angles 7 and 8 also add up to 180. Okay? And so an example, okay, so we said, this is an example of vertical angles. Let's kind of sum up what we already mentioned. So examples of vertical angles, well, there'd be angle 1 and angle 4. Another one would be angle 2 and angle 3. All right? Okay, and then an example of supplementary angles would be angle 1 and angle 3. Another one would be angle 5 and angle 7. All right? They have to be adjacent to one another. Another important concept, let me use a different color here. I guess we use orange. So let's say you have angle 1, and let's say you had angle 6. All right? Angle 1 and angle 6. Okay? They're going to have the same exact measure. And those are called alternate exterior. Think of this line, right? Angle 1 is to the left of the line, angle 6 is to the right. So that's the exterior, outside of that line. So those are called alternate interior. Okay? Alternate interior. Okay? No, excuse me, I made an error. Let's fix that. Okay, I meant to say this, alternate interior. Angle 3 and angle 6. Okay, they're inside those parallel lines, right? So angle 3 and 6 would have the same identical measure. Okay, so an example of that, example of all alternate interior. So many angles here, it's easily to get confused if you're not careful, right? So if you make a mistake, just look at it again and say, oh yeah, I meant that one. That happens, okay? Especially if there's a lot going on, okay? So example of a pair of alternate interior angles would in fact be the measure of angle 3, which is going to equal to the measure of angle 6. Does that make sense? Okay, and another set would be the measure of angle 4. That should equal to the measure of angle 5. Okay, that's another set. And then we have one more, and this is what I was thinking. I kind of jumped the gun here. Let's use gray actually. Then we have this angle, and then we have this angle, and those are called alternate exterior. Okay, alternate exterior. So examples of all exterior. Okay, would be the measure of angle 1, and that's going to equal the measure of angle 8. Another pair would be the measure of angle 7, all right, and angle 2. Okay, that'll be another example. Okay, so another example would be the measure of angle 2. That's going to equal the measure of angle, what did I say? 7, right? Okay, does that make sense? Okay, I know it's a lot of information. It gets a little dizzy, right? You look at all these different angles, but once you study them, you will remember them pretty easily. Okay, so, okay. Now, you may not like me. I'm going to mention another type, right? Just one more. Okay. Black. Okay, so I'm going to label these in black. Okay, so let's say you had this angle. And let's say you had this angle. Well, those are called corresponding angles. And they're also equal to each other. Oops. All right, so that means that the measure of angle 1 is equal to the measure of angle 5. Okay, does that make sense? They will add up to 180 degrees. Okay. Another pair of corresponding angles would actually be angle 2 and angle 6. Does that make sense? Another pair would be angle 4 and angle 8. Another one would be angle 3 and angle 7. So there are 4 sets of corresponding angles in this diagram. But, so yeah, that is basically all the types of angles that we can probably work with here. You're going to see these terms, or this type of terminology, it will appear quite frequently depending on what diagram is given to you. If you're dealing with lines, then these types of angles will appear, right? They'll be mentioned. Okay, so yeah, a lot of information here. Okay, all right, so okay, so that would be how to label these angles properly. Now, just got one last thing to show you, and then we'll finish. Okay, I'm going to draw another diagram. I didn't like the way that came out. I'm trying to draw these as accurate as possible, as neatly as possible. So we have these two lines that are parallel. Then we have a transversal. Let's label some angles here. Okay, so we're going to label this as 7, 6, 1, angle 2, 4, 3, 5. And the measure of angle 8, this will be 8, right? So the measure of angle 8, let me just label it. let me just write 68 degrees. Actually, you know what? Let me do this. Be a little less clutter here. Okay? So let me just do this. And we're going to call this angle 68 degrees, 35 degrees. So the measure of angle 8 is equal to 35 degrees. All right, so we know one of the angles. All right. So let's find all the angles. Okay. Well, the first one's given. The measure of angle 8, we said, was 35 degrees. Why don't we find the measure of angle 6? Well, if you have measure of angle 6, you notice that these two angles are adjacent, which means they have to form a straight line. So if they form a straight line, then it's 186 degrees when you sum the angle 8 and angle 6. So you take the difference. You just take 180 and you subtract the 35 degree angle, and then you're going to get 145 degrees. Okay? And now we want to find angle 7. Well, angle 6 and 7 are vertical lines. So if angle 6 is 145 degrees, then the opposite angle, 7, would in fact equal exactly 145 degrees as well. Now look at angle 2. So angle 8, which is 35 degrees, and angle 2 are alternate interior angles, and they have to be equal. So if angle 8 is 35 degrees, then angle 2, remember that's equal to angle, the measure of angle 8. And that's going to equal 35 degrees. Sorry. I'm writing the wrong here. Sometimes when you write a while, your hands get a little sweaty, and then the stylus kind of slips on you. So if I'm constantly correcting and erasing, that's the reason why. Just want to make sure you can read it. All right, then we want to find angle 3, which is adjacent to that. Remember, angle 2 and angle 3 are supplementary. So whatever angle 2 is, it needs to be subtracted from 180 in order to get angle 3. So angle 3 is equal to 180 minus 35, because angle 2 is 35. And that gives me the difference of, so basically 180 minus 35 gives me 145 degrees. All right. Okay, we're almost done. So let's find measure of angle 5. Well, measure of angle 5 should equal measure of angle 2 because they're vertical. And we said angle 2 is 35 degrees. Well, the opposite angle, 5, is vertical, a vertical angle. So measure of angle 5 is, remember, it's equal to the measure of angle 2. So that's going to equal 35 degrees. Does that make sense? And then now we need to find the measure of angle 4. So the measure of angle 4 is going to be supplementary to angle 2 and angle 5. So you just gotta pick one, right? So let's pick angle 2. So the measure of angle 4 is basically 180 degrees. Oops, again, did that again. 180 degrees, take away 35 degrees, and we get 145 degrees. And we have identified and found all of the angles that were given in the diagram. Okay, so let's finish up the lesson with a comment and we'll finish. So, you notice this video had a lot of terminology. Once you identify the terminology and the rules of these intersecting lines, you should be able to find any angle that's given here in this particular situation, all right? Okay, well, thank you for watching. I hope this video was very, very helpful, and I'll see you in the next video.